All right, hello Year 12s. Today we are demonstrating how you will set up your summative catalase prac for Year 12 biology. So first warning, we're going to be using hydrogen peroxide for this experiment, 6%, pretty strong. Hydrogen peroxide is a strong oxidizing agent, so we want to make sure we're wearing gloves. You'll be wearing glasses and we wear lab coats so that nothing gets on our skin. First step of our method is to carefully measure out 6 milliliters of hydrogen peroxide that eventually we're going to be adding to our capsicum solution, which is where we get our catalase. With a pipette, carefully give it a squeeze. Squeeze first, if you can see my hands. Squeeze, drop it in, unsqueeze, and you should be able to get a good 3 or so mils. We then take this to our measuring cylinder and we add it to it. This one has already got its 6 mils ready to go. I prepared this one earlier, and always be very, very careful that you can get the meniscus touching the 6. All right, and always have on a flat surface, get down low and see whether you can see that meniscus. Once we have our 6 milliliters of hydrogen peroxide, we're going to leave that to the side, and that's going to sit at room temperature. Step 2, with our Catalase solution, again of capsicum, we need to get 4 milliliters of the green juice, not the foam. Foam's useless. We need the green juice. So again, with your pipette, down low, down the bottom, as you can see along here, give it a squeeze, drop it below the level of the foam, release. And there's the green catalase. Using our measuring cylinder again, keeping it flat, let that dribble into the measuring cylinder, get down low, have a look, make sure the meniscus is touching the 4. That's not enough, squeeze again, drop it down, bring some up, and we carefully dribble that into the measuring cylinder, like so. And here we have our 4 milliliters of Catalase solution. Our Catalase and our hydrogen peroxide will be mixed together in a 100 ml measuring cylinder. Once these two are mixing together with a timer, we press start to time for 1 minute. Once 1 minute is finished, we're going to see a whole bunch of foam having risen up the measuring cylinder. Now, these Catalase solutions are being exposed to different temperatures. As you can see at the side of the room, we have heat baths. Our heat baths are simply warm water that we can set to a temperature. We'll be using different temperatures. For this experiment, we have 60 degrees, 40 degrees room temperature, and a cold fridge temperature. As you can see, we have Catalase ready to go in our heat bath to make sure that they are at the temperature to investigate temperature's impact on enzyme activity. If we do it at room temperature, we'll see a certain result, but we need to measure what's happening at a range of temperatures to get a range of data. So those measuring cylinders are currently at 60 degrees, and we'll test this one next. So here I have my 60 degree Catalase solution. I'm going to carefully pour that into my measuring cylinder. And straight away, as soon as I possibly can, get my hydrogen peroxide, add the hydrogen peroxide to the Catalase, start the timer. We're going to let this timer go for about 1 minute. And once that minute's up, take a measurement of the amount of foam that has produced from the introduction of hydrogen peroxide. As we approach 1 minute, stop, ooh, close. We then have to record how many milliliters of foam have produced. Again, get down low, reading on the graduated cylinder's measurements, how many mils of foam have occurred. In this trial, so far it looks like there's really minimal foam whatsoever. When it comes to the discussion of our results, keeping in mind this solution and this Catalase enzyme was kept at 60 degrees, trying to ensure we make some connections between what 60 degrees might do to the Catalase enzyme in order for it to react with and break down our hydrogen peroxide.